Now that we have thoroughly discussed exponents, we are ready to learn about roots. The symbol for a square root looks like this. When there is a number under the square root, we simplify the expression by finding a number whose square is the number given. For example, 7 times 7 equals 49. So the square root of 49 is just 7. 49 is actually a special number because its square root is a whole number. There are not many numbers that have this property, and they are easy to find. We just start counting. 1, 2, 3, 4, 5, and we can keep going if we like. Then we square each of the numbers that we counted. 1 squared is 1, 2 becomes 4, 3 squared is 9, 16, 25, etc. We have just found the first 5 numbers whose square root is a whole number. These are called perfect squares. Pause the video now and take some time to write these perfect squares in the box on your worksheet. As I already mentioned, we can solve for the square root of a perfect square exactly, but generally it is not possible to get an exact value for a square root expression. Even the best mathematicians and fastest computers can still only approximate the value of a square root of a number that is not a perfect square. There is no step-by-step process of finding an exact value of a square root. Calculators can get very good approximate answers, though. When I used the Google calculator for the square root of 2, it gave me this output. The number you see here is the square root of 2 written in decimal notation, but cut off. The actual answer is an infinitely long decimal of seemingly random digits. So this continues indefinitely. You can see why this would be a hard number to calculate. It would take an infinite amount of time. Fortunately, in many cases, we don't need more than a couple decimal places of precision. If we don't have a calculator, the perfect squares can help us to approximate the answer of an expression with a square root. For example, let's say we want to take the square root of 23. To do this, we just need to check which perfect squares 23 lies between on the number line. 23 is greater than 16, which is the square of 4, and is less than 25, which is the square of 5. So the square root of 23 should be somewhere between 4 and 5. When we calculate the answer with a calculator, we get that the square root of 23 is in fact approximately 4.796. So our guess that the square root of 23 was between 4 and 5 was pretty accurate. On the GED, you will want to use your calculator whenever you are allowed to solve for square roots. You should work through the problems on section 2 of your worksheet now. The next video goes over solutions to the starred problems from section 2.